This is section 3.4, comparing measures of center. So how do we decide whether to use mean and standard deviation? And these go together, we said, or median and IQR to summarize. So mean is a measure of center, standard deviation is a measure of spread, median is a measure of center, IQR is a measure of spread. And how do we know when to use which? So our goal should always be to choose the value that is a good representative of a typical value of the distribution. And so as it turns out, the mean and median are better for symmetrical. And we will only know this by whether we have symmetrical or not by looking at the distribution. So we're always going to graph first. And median and IQR are better for skewed. If we have access to data, then the first step is to look at a graph of the distribution in order to determine the shape. Which of the following distributions is symmetric and unimodal, and which is skewed? So these are from your textbook. Over here, this one looks to be a little bit more symmetric. So this one's symmetric and unimodal. It only has one mode. This one here you can see is skewed, and it is skewed to the right. There's a long tail to the right. So if we don't have access to the data or are unable to produce a graph, then we should try to determine reasonable shape for the distribution based on our knowledge. So over here, since we can see them, we would want to use median as a measure of center and IQR as a measure of spread to describe this data. And over here, it'd be more appropriate to use mean and standard deviation. So the salaries of all employees at a large, oh, I'm sorry, excuse me. So if we want to predict some of these distributions, even though we don't have the data, we just need to kind of think through what they would look like. For example, the salaries of all employees at a large company. If we were just to draw an idealized version of this, probably most salaries, would be somewhere down there, and then there'd be this long tail where, you have your vice president, CEO, and so likely this type of distribution of salaries would be skewed right. At the age of death of a random sample of people in Massachusetts. So if we took a random sample of people in Massachusetts, we'd probably expect most of them to be older with a few younger people. So again, this would likely be a skewed distribution, but this time skewed left. IQ scores across a random sample of people. So those would likely be symmetric and unimodal. If the distribution is symmetric but contains an outlier, so we're talking about a distribution like we look at it, symmetric, but over here we've got this outlier, then we typically want to use the median, because remember, if you have an outlier, the mean will get pulled in the direction of the outlier. What do we do if there's more than one mode? So let me next page. Well, that depends on the situation. So we may need to investigate further about the bimodal aspect of the distribution. Is it because we've combined two different groups, for example, heights of men and women, into one data set? In this case, it's usually more useful to separate the groups and then look at the shape of each distribution. For example, the following histogram displays the finishing times for two different marathons. One marathon consisted of a small number of elite runners. The other marathon included a large number of amateur runners. What do you think is a typical time for each? Okay, so our observational unit here are marathon runners. And if we kind of look at this, we're sort of seeing maybe two different distributions combined. It kind of looks like we've got one here and then a second one here. So maybe a typical time for this first distribution could be 150 minutes, whereas the typical time of the second distribution might be more like 250 minutes. So this is, if you look at it, it looks bimodal, and it's because there's two different types of data mixed in together. So which measure of spread and center should be used when comparing two or more distributions? So maybe you're comparing two distributions, one turns out to be symmetric, the other skewed. If one of them is skewed, then you should use the median and the IQR for both distributions. It wouldn't be good to use the median for one and the mean for another. So we want to be consistent, and if one is skewed, then we should use the median for both. So the following histograms show the two times for these marathons separated. What is the shape of each distribution, and which measure of center? Well, this one, I'd say they both are slightly skewed to the right. They both have a little bit of a tail, like over here too. So I would definitely use median for center and IQR for spread. So that summarizes comparing measures of center and spread, really, for different types of distributions. We have one more section, 3.5, which we will get to next.